Welcome to the Munro Live podcast. I'm Tom Perche, Director of Electrification for Munro Associates. I'm here to interview my soon-to-be new friend and hopeful colleague, Matt Ferrell. So a little intro to Matt. Matt is a tech enthusiast, as a self-proclaimed sort of format, if you will. But he's also a user interface designer, something I've done a little bit of my own in the distant past. And like me, he's a bit of an audiophile, although I tend to play the music, and I suspect he listens to it more. And then there's the photographer Matt, the videographer Matt, the graphic designer Matt, gamer Matt, content creator Matt, and specifically the YouTube creator for Undecided with Matt Ferrell, otherwise known as @UndecidedMF. So you seem to have a rather good focus on sustainable and renewable energy technologies, subject very near and dear to my heart. And we're going to explore that topic amongst several others throughout the course of our podcast here today. So with that, did I leave out any specialties in your intro, Matt?
No, that's a pretty all-encompassing thing that you've covered already. So yeah, that's good enough.
Well, I'm going to expand on it anyway. I will call you the geek's geek. And what does that mean? I'm a geek. I self-proclaimed, wear it as a badge of honor. I tend to dive deep into the technical side of it. I tend to find myself always in a position of having to explain it to others that aren't on the deep technical side of it. Yourself, you've kind of come in from, not having the baggage of the deep technical side of it, being a content creator and that, history. None of that was engineering or designing physical hardware. You did write some software, I presume, as part of that, so you're not completely ruled out. So I look forward to this discussion, basically, given that you've taken this to a level that I only wish I had time for. So you will have in-depth topic knowledge far beyond my own in some of these areas we'll talk about. So I really like that. I enjoy the opportunity to learn as I'm interviewing somebody. So with that, I think we should get started. In the news some weeks ago, we learned that Tesla, in its altruistic way, has decided to offer up their NACS charging standard for the rest of the world to use. And surprise, surprise, a number of major OEMs jumped right on the bandwagon. You look at the connector difference between our big bulky J1772 with this CCS1 connector for DC fast charging. It's a big, burly, bulky thing with cables that are real heavy. And then you look at this nice NACS unit that's svelte and really easy to hold and not so many connections. And it's not hard to imagine why people like it better. So with that, I don't know what your thoughts are on it. I have some of my own. And I'll lead off with my first thought is that it was a little bit like years ago when Tesla offered up all their patents in their altruistic way, saying, hey, follow our lead, and you too can be EV manufacturers. And I thought to myself then, what better way to stay 10 years of your competition than to give them all your old stuff? Wonderful idea. And a similar thing now, I think, with NACS. So, what is this? I think they've got a bit of a problem with that they know they have to develop, and they're finally starting to deliver their fourth generation of supercharger. And it has this capability of 1,000 volts. To me, one of the great ways to fund the transition to having all the stations capable of that would be to have all your competitors pay for that. So anyway, that said, I'm curious of your thoughts, Matt. Let us know what you think about this new thing. Are we going to all adopt the new standard and walk away from the old one, or will it linger for a while?
Here in North America, 100%. Yeah, it's a long time coming for me looking at this. It was like we needed one good standard to stand behind in the country for things to kind of really accelerate. And we're seeing CCS2 over in Europe, where that's become the standard over there. But CCS is like you mentioned, such a clunky, awkward, unwieldy thing to plug into your car. And then here's this beautiful, sleek, Tesla charger. It's like, well, why can't we just go that path? So when Tesla put this out there a number of years ago, it was like nobody was taking it, nobody was doing anything with it. And I was like, why is nobody going forward with this? So when the NACS kind of standards body kind of came out, it was like watching like a crack in a dam form. It was like that first company comes out saying, we're doing it, the next one, then the next one. I was like, okay, here we go. We're finally getting that standard that we desperately need. Because the user experience of charging networks sucks. It's absolutely awful. And so we need to get around one standard. And the fact that they're going to theoretically have that 1,000 volt capability is a good sign too. And Tesla being a shrewd company, I agree with you that they've kind of played this extremely well. Like they're playing a game of chess here. The way that it's been opened up, they're going to benefit from this with like the IRA trying to blow out the infrastructure for electric car charging networks. It's like, this is the perfect time to capitalize on that. And Tesla's going to reap the benefits of all of this. It's a very smart move.
And of course, we will reap benefits as well. To your point, it's not hard to have an unpleasant experience at a charging station. I have a British colleague who has a conspiracy theory that he uses to explain why the oil companies are so interested over there. He says he's got evidence that the oil companies are systemically causing bad experiences at electric vehicle charging stations for obvious reasons. And I don't know that I can go that far over here, but certainly they have some explaining to do how it can be so dysfunctional. So here's a way to kind of leapfrog into something more reliable. Hopefully it'll stay reliable with the influx of additional users that will obviously come. So, good work, Tesla. Way to stay 10 years ahead of everyone else. So, but latent in this existing supercharger standard is our, woeful infrastructure that we have here at 480 volts, 3-phase. So that kind of began where their advantage was at 377 volts of capability, which is, grabbing a single phase of the 480, which is more than what J1772 is able to do with AC charging. So that was a bit of an advantage right there. But, more importantly, the world is now caught on to 800 volt architectures. So I've had the experience of looking at a few of those recently. Some are pretty darn innovative. Hyundai with their Ioniq 5 has this unique boost converter that goes from that 400 volt AC infrastructure quite nicely up to 800 volts, which is their battery voltage, with an integrated boost converter they put inside a motor and an inverter. So that was kind of cool. You've got boxes that are dedicated to the same cause on Lucid and Porsche vehicles, optional boxes available on Porsche vehicles. You've got the notion of 800 volts as a direct connection seemingly being the obvious way forward. But for those who can't plug into an 800 volt charger, you have 400 volt chargers, and some sort of boost converter is required. So Tesla must obviously see that their future is also focused on 800 volts, and now they're bringing out the capability in their charging stations. So good work for them, good work for everybody. It's going to keep people busy keeping these charging stations upgraded for a while, so it's going to be a boost to the economy as well. So I don't know what your thoughts are about 800 volts versus 400. Last variant is, GM and their Hummer, very clearly an 800 volt pack inside, but operates at 400 volts by taking the 800 volt, partitioning it into two 400 volt batteries, rewiring it in parallel so you can drive down the road. But when it does encounter an 800 volt DC fast charge, it can charge directly at 800 volts. So, what are your thoughts? Are we going to see 800 volts as a widespread target, or is it going to be niche applications? What do you think?
I think it's going to be widespread it's going to take a while, but I think it's going to end up being the widespread kind of standard, mainly because it's like everybody wants like the fast to fast charging, and like 800 volts unlocks some additional benefits with these newer battery technologies coming to market that can charge in minutes. It's like we need that better infrastructure. It reduces thinner wires, reduces the heat loss, all those kind of things. It has all these benefits that are going to be really key for EVs specifically. So it makes sense why we want to go 800 volts. You brought up the Ioniq 5. It's one of the reasons I'm actually interested in that car. I keep eyeballing that car as my next car. That's one of the reasons.
Interesting about the way they did it too. They have some patents that you can look at to describe how it's all working, but they didn't implement all the things that are shown in their patents. They've left out some components that saved a lot of money, but introduces some minor amount of loss at 800 volt charging that I don't think anybody will ever notice. They'll just be so happy to charge at the native 800 volts. So I won't go into that here, but I see it similarly. 800 volts is an inevitability. There will be lots of cases where it doesn't make sense to transition. My first application at 800 volts led me to believe it was way distant future, and it was back then, but mainly because of the componentry. If you go above 600 volts, it's really hard to buy parts, connectors, contactors, all the different components that go in a battery. So, all right, so we're common on the 800 volt future. All right. So
we're kind of in lockstep right now.
So then you get into the DC fast charging aspect of this. And, this is fascinating to me because, for years we've known that fast charging wasn't the best thing to do to your car. Yet people do it all the time. People actually use it as criteria for what would allow them to buy an electric car. If they can, top off their charge similarly to the way they do their gasoline or diesel vehicle, then, it's one less thing for them to complain about. So that being the case, you've got this new report that came out in Inside EVs this week that talks about the statistical degradation, what happens on real cars. They spotlighted some Model 3s and Ys where they were either 90% fast charged, or 10% fast charge as it was. You can read about it if you like. But what's your take on that? Are we seeing a reduction in the barrier that is focused around this DC fast charging and the degradation of batteries, or will we just not care?
I think ultimately we're just not going to care. I mean, think about our phones. It's like people do wireless charging on their phones, even though it actually is a little harder on the batteries because it's more convenient and they like it. So it's like, we're going to do what we want to do. And if you want to fast charge your car 90% of the time, you're going to do that. So for me, the fast charging issue is less of an issue over the course, the life of the vehicle. Like if you looked at those graphs in that article, it was fascinating how the fast charging, it did go down a little faster, but then they kind of met up again
it was
after
almost
a certain period of time.
Yeah, it's like as you get down to about 90% of your remaining capacity, suddenly it's almost as if the battery's been conditioned to fast charging, and now it's even a little better. So it didn't work exactly the same on the 3 and the Y, but it was very interesting to say the least. But what it does do is it kind of points out the other problems that are associated with that, and that is more about how low do you let it go before you charge, and how high do you take it when you do charge? These things, I think, will remain sort of hidden advantages for those who know about them and disadvantages for those who don't. So, this is my own study of battery cell chemistries shows that in those extremes of state of charge, particularly above 70 or below 30, you get a lot of mechanical changes that occur in the cell, and it kind of distorts it. It expands when you charge, it contracts when you discharge, it expands over time. So, what are your thoughts about that? Are we going to continue to try to get as much range as we can out of the car, or are we going to try to focus more as a middle-of-the-road state of charge? Maybe you can describe what you do in your own car. Do you consistently discharge it all the way, or do you try to keep it in the mid-range?
Yeah, I understand the whole thing of you don't want to hammer the battery all the way to 0 and go all the way to 100. That's when you're going to be really hurting the battery. So I tend to keep my car between that 30 and 70% state of charge most of the time. But I'm also in the know, and I'm not the normal driver who's not going to know this. So I think the future of this really comes to software around the user experience, where the car itself can try to manage the battery management system, trying to prevent the user from causing undue damage to the battery. I think you see this in smartphones right now. Like with an iPhone, you plug it in at night when you go to bed and you get up and you unplug it. Well, it's not charging all night. It learns when you're getting up on a typical day. And so then it will limit when it's charging. It will just trickle charge overnight, and then it will start doing the main charge in the morning right before you get up. So it's trying to manage it so that you're not going to be like hammering the battery. I think cars are going to end up doing something similar, where you don't have to know that whole 30, 80% kind of range. You can just do what you do, get home, plug it in, and you walk inside, but it's actually only trickle charging your car. And then it will like kind of slow things down in a way to help prevent hammering the battery. I think software is going to save us here.
Yeah, I think that we're already seeing some benefits of that with the Inside EV's report we talked about. The very fact that they've been able to make DC fast charging seemingly, inconsequential to the average Tesla owner, to me speaks to the software that is behind all that. A lot of people go, yeah, I have 250 kilowatts of charging at my fast charger. And then they look at the data and they go, wait a minute, it only actually charged at that rate for like 5 minutes. And then it started tapering off. What happened there? Well, again, the software knows, and it keeps things in check. And I think that's, a real testament to good software and, what the results of taking the extra time to get it right really turns into. So good stuff. Then you get on to, all right, now I have this tremendous battery on wheels. What else can I use it for, right? And I know this is a subject near and dear to your heart, as it is mine, although you're way ahead of me. So I will look forward to learning some things from this session. Remember reading years ago about vehicle to grid, and now there's all the focus on vehicle to load, and this big broad category of V to X, if you will. So some of the key issues about that are, when we have a warranty on our cars, the U.S. government, for example, mandates an 8-year, 100,000-mile warranty with some wiggle room for interpretation on what that means, but it's based on miles and calendar, not kilowatt hours. So wait a minute, this warranty, who's paying for that warranty as I use it to prop up the local area grid or, provide energy for my home? What are your thoughts on that? You've looked at it a lot more deeply than I have, I believe. So I'm really interested in your view.
Yeah, batteries changes the game in so many different ways when you're talking about a car, because it has multiple uses they never had before. So we can't just look at it as, it's got a 100,000-mile warranty or something on it. We have to think about it in a different way. So I do like the idea of changing warranties and doing it based on like kilowatt hours in versus out, or some kind of warranty around how much the battery has been hammered or used in a given time frame versus how many miles you've driven. Because vehicle to grid, look at the Ford F-150. Like how big is that battery? It's like the equivalent of what, 6-7 Powerwalls, something ridiculous. It's like you could power your house for an entire week off of that truck. It's like, I want to be able to use my Tesla Model 3's battery in an emergency situation of my house. Like if the power goes out, I could plug it in and power my house for days. It makes so much more sense. But at the same time, the current warranties are not going to take that into account. And when you're using batteries for vehicle to load or vehicle to grid, it really does hammer the batteries. It really does shorten their lifespan if you do it on a frequent enough basis, because it is dragging the battery down to close to 0 up to 100 if you're using it the way that the grid wants to use it. So you have to account for that in the scenario if we have vehicle to grid. Tesla is like one of the few companies that has not really addressed this. They've never really come out and said they're going to do it. And I've been curious as to why. Probably because they have the Powerwall. They don't feel like they need to, because they have a product that can sell that will give you this stuff at home. But again, one Powerwall, it takes several Powerwalls to make the equivalent of a Model Y or a Model 3. So we already have the battery. Let us use it how we want to use it.
All right. Well, that kind of speaks mountains, if you will. The whole notion of the way we warranty it today, for a while there, it looked, though, that maybe they were going to gravitate towards the battery not being owned by the user, and that might be a way around it. Maybe my local power utility will buy the battery and I'll lease it from them or something like that. But we haven't seen much of that happening. You've got, the battery swap technology that was all the rage 15 years ago, then it wasn't, and recently took apart some Tesla vehicles that were quite obviously designed to have the battery easily swapped out. But NIO seems to be one of the only real credible players in the game that's doing battery swap in any kind of reasonable scale. There's some, heavy-duty truck applications that make sense for battery swapping, but do you think there's a battery swap in the future that might help address this concern? Or is that just a mile too far?
For me, it feels a mile too far. I don't think battery swapping is going to become a thing. Like to charge, like the alternative to charging as battery swap, I don't think is a thing. But a more swappable battery to be able to change it out if the battery needs to be changed because it's near end of life, I think that is something that we should be seeing more of. But unfortunately, we're seeing the opposite happening. Like with Tesla basically integrating the battery into the structure of the car makes that kind of a non-starter.
Yeah, it does.
So there's problems there of they're doing that to optimize cost of manufacturing, but for the long-term lifespan of how we might want to use our car batteries, it's not a good thing to do it that way. So I'm kind of torn. And to kind of tie back to what you just said about the utilities, putting some skin in the game, potentially maybe they own the battery pack or something. That's something similar that's happening in virtual power plant systems, where you have a power wall in your home and you sign up to participate in a virtual power plant. The utility typically will pay you out for how much they use your battery. And there are some areas around where I live, like in New Hampshire, there's a program run by utility that they actually basically pay for the power wall. They put it in your house and you get the benefit of the power wall, but they technically own it. So it's like that is something that we're seeing on the home side of the battery market. And it could be interesting to see something like that maybe on the car side of the market as well.
Very cool. See, now that's what I'm talking about. Things that I learn by being the interviewer. So yeah, that is really exciting stuff. And it makes sense. You've got all that energy and we have a problem with our grid. We need as much, microgrid stabilization as we can get. And what better way than to make people's car the way of doing that, or the power wall in the case you described. And that's a good way forward. So it kind of gets me into other subjects related to the home, right? I know you're kind of an aficionado around home automation. It's a subject that's near and dear to my heart as well, although I'm nowhere near as vested as you are. I haven't gotten much beyond the doorbell and the video cameras around my house and the occasional Alexa app here and there. There's a lot of concern about the user public and what might be surveillance. And even though most of the stuff I bought specifically so that I could do my own surveillance, I know I'm being surveilled too, but you know what? It doesn't matter to me. It's a little bit like searching for something on the internet and finding, a Taylor example of that showing up in my news feed, minutes later, or a verbal discussion I'm having with my wife that shows up in my news feed next. So, to me, it's about, you live a clean, honest life and you're not really worried about people knowing when you go to the bathroom or whatever. The targeted advertising to me is a big benefit. I don't like shopping. And when I'm looking for something, I love it when it shows up in my inbox. So, I don't know what your own thoughts are. You've taken it a lot further. I don't know if you've run into any cases where you were worried about, it being used in an inappropriate way. But, tell us about your home automation experiences and where it's going.
Yeah, some would say I've gone too far with my home automation, but my view is similar. Yeah, yes. There's the wife acceptance factor doing something with a smart home. To account. Yeah. As far as like the marketing angle when it comes to smart home stuff, I don't have a problem with that at all. I'm kind of in a similar boat to you, but there is an aspect to privacy that does have me concerned, and it's when you have a company like, let's say, Amazon. How well are they maintaining data integrity around the data they're collecting on you? If there's data breaches, is it going to cause problems? So there's a side of it that I do have concerns with, but if Amazon knows how often my lights on and off, I don't care if they know that. Yeah. So there's a kind of a sliding scale as far as privacy is concerned, but there's so many benefits that you can get from home automation. If you're just geeking out on like energy use, it's like I have a smart electric panel from a company called Span, and there's a bunch of these on the market now. I know exactly where my energy use is going in my house, circuit by circuit, device by device. I know exactly how much I'm spending on charging my car. My solar panels are how much battery use is happening. And with these systems, you can create these automations where it's like you're only charging your car if you have excess energy production from your solar panels. So you're basically only charging on sunshine. You can do all these things in an automated way where you don't have to think about it. You just come home, plug your car in, and then the house takes care of it from there. Other things where it's like getting alerted when you're using too much energy. Like in my previous house that I was in, I had a dehumidifier I had put on kind of a smart outlet, and I had put it on I thought it was only running a certain hours of the day, but something had gone wrong and it was running all the time. And because of the Span, it alerted me saying your energy use seems unusually high. And I looked into the data and it was like, oh wow, this circuit's been running basically 24 hours a day and it's been costing me an extra like $25 a month. Solve that problem, turn it off, and kind of Bob's your uncle. I've just saved some money and saved some energy. So it's like knowing where your power is going is kind of a huge part of this. But as far as like in my house, I've got a smart panel tied into, I've got cameras all over the place that can act as motion sensors as well. I've got smart shades in my house, in my new house that I just built. So during certain times of the day when sun is beaming into the windows, it's going to be heating a room I may not want heated because I'm trying to air condition it. I can have the windows automatically drop the shades, whether I'm there or not, which can help with, again, energy use by reducing how much I have to run the AC. There's motion sensors, so if we're empty for a certain period of time, automatically turn off lights if you've forgotten to turn them on. There's conveniences on top of that I've been doing in my house around like washer and dryer. Like your washer is done. It may be done for 20 minutes and you didn't realize it. It's like you can have a light turn on in the kitchen that goes green, meaning that it's done, or it barks something out on the your smart speaker saying, hey, the laundry's done, go check it. So there's all these little things that you can do from conveniences to all the way to saving energy that I absolutely love how
you're giving me ideas.
Making these things talk. Yeah. It's a slippery slope. Once you start to go down here, it doesn't stop. It's like you find all these new ways you can do it.
Yeah, it was kind of comical. I recently upgraded our washing machine to a new GE smart washing machine. And because I set it up, I'm the one who has the app on my phone. So imagine my wife's surprise when I woke her up and said, you left the laundry in the washer last night. How do you know that? My phone told me. So, anyway, I can only imagine integrating that in with a larger system, along with, natural gas consumption and water consumption and all these different things. Yeah, we all would do well to conserve our energy, if for no other reason than to save money. So, good new technology that isn't all that hard. I think that the people who don't try to implement this themselves, they either have some paranoia about security of it, or they just are intimidated by the inherent difficulty. But have you found any particular automation brands, if you will, that make it easier or more difficult that you would plug here in this moment?
Yeah, that's a good question. I'm an Apple user, so I'm using Apple Home for most of my stuff. But there's free solutions that you can do. Like there's something called Home Assistant. It's on pretty much any kind of computer you can think of. You could get a little Raspberry Pi, or you could run it off your Mac or PC. It just runs on anything, and it's gotten way easier to use now. It used to be awful to use, like just a few years ago. Like the user experience was really bad. It's actually great now. So it's really easy just to go and buy like any kind of smart device that has the Matter label. It's a new standard in the smart home industry, which means it'll work with Google, it'll work with Amazon, Alexa, Apple. It works with everybody. So it doesn't matter what platform you choose. If you buy something that has the Matter sticker on it, it'll work with something like Home Assistant or Alexa or Apple Home. So those would be the things I would kind of call out. So there's free ways to get into this with Home Assistant. And then there's technology that's very affordable now. You can find it on Amazon. Just go searching for Matter Smart Outlet or Matter Light Switch or Matter Light Bulb. Tons of stuff out there now.
Good stuff. Again, more knowledge for Tom. Anyway, obviously our users are also likely to be highly appreciative of these viewpoints and maybe a few shortcuts along the way, so thanks for that. So, more about the home. All the rage now is about heat pump systems. This is something that I discovered many years ago with just simply trying to understand air conditioning systems on cars. My first electrification experiences were implementing high voltage AC compressors on a high voltage battery and trying to understand the energy consumption. And I was turned on to this parameter that's associated with air conditioning called coefficient of performance. So this is like what appears to be the use of a lot more energy, but it's not. So, coefficient of performance of 3 is this. It's as if you've done the work 3 times of what the energy consumption might have dictated. So if I'm making heat like I do in an air conditioner, I'm not really making it, I'm moving it. And the side I move it away from gets cold, and the side I move it to gets hot. So, now we have a focus on maybe utilizing that same sort of thing, but from the hot side. We always knew about air conditioning. We cared about the cold side a lot. And that hot side was always this nuisance. If it was in a car, it's always the frontmost radiator. It gets the most attention from the frontal area, the wind blowing through the car. Outside, there's this big condenser. It's got a fan on it. It's really noisy. That's not the desirable part of it until you turn that into a source of heat. So, what are your thoughts about that? Are we going to see widespread adoption of heat pumps? I saw that you had done one the rather expensive way. Do you have regrets about that now that these other air-based systems are becoming more efficient and more capable in the cold? So what was your experience and what would you do differently?
Well, my opinion at a high level is I think we need to heat pump all the things. It just makes so much sense. Like you called out the COP of like 3 or 4 that you might see. Why would you not want that? For me, for my house, I did a ground source, often referred to as geothermal heat pump system. So it's not pulling the heat from the air, it's pulling it from deep in the earth. Definitely the more expensive way to go, but it is more efficient than air source, but it only makes sense for long-term kind of goals. So if you're looking at like, I just want something in my house that's going to do well for me for the next 10, 15 years, air source is going to get you where you want to go. I was looking at like 20, 30-year time spans. And so I was looking at like, where can I put my money to make the most sense for me? And ground source kind of made more sense. My wife agreed when we kind of like crunched the numbers and looked at what the benefits were. But no matter which way you go, air source, ground source, heat pumps are just kind of a no-brainer. The biggest problem that I often hear whenever I've talked about heat pumps is they don't work in the cold, because when it gets to a certain temperature, heat pumps really start to struggle. So you get closer to get to 0 degrees Fahrenheit, the more that COP just starts to drop. So it goes from 3 down to 2, eventually down to 1. But that argument doesn't hold water because most of these systems can be done in a hybrid fashion. So like if you're in a very cold climate that gets like negative 40 degrees, like if you're in Minnesota or something like that, and it gets crazy cold in the winter, you could have a hybrid system where you have a heat pump with a resistive heater in it, so that when it gets below the point where the heat pump can't really handle it that much, it just flips over to a regular resistive heater, which has a COP of 1. It's still fine.
Yeah, that's what I was going to say.
So it's like,
COP of 1 is not a bad thing. That's kind of what we're all used to.
Yeah.
If we can get to 1. Yeah.
Yeah. And then if you look at the entire time frame of like when the system's going to be operating over the course of a year, how many days of the year is it going to be that cold where it's going to be running at a COP of 1? It's a handful of days, maybe a couple of weeks at most. And the rest of the days, you're getting all that benefit of the heat pump COP. So it's like, to me, it's like, it makes perfect sense, but oftentimes the arguments against it tend to come from a very black or white point of view on it. Like it either has to work 100% of the time or it's no good. And I'm definitely not in that camp. You can definitely make them work financially and economically, and just from the efficiency point of view. They are there today. And there are, as you mentioned, there are cold climate heat pumps hitting the market like right now. They're starting to come out now. And then, they can go down to like negative 20 degrees Fahrenheit and maybe even a little lower than that. So it's going to get more reach now with these cold climate heat pumps. So there's a big push in that direction. I think we're going to see this in the next, 10, 20 years. It's going to be like the norm. It's like not getting a heat pump is going to be strange.
And now we're seeing COPs of up to 6-to-1. So, the argument's becoming quite compelling. So just to translate that, if you have a coefficient of performance of 6, this is like using 1/6 the amount of energy to heat your home that you're used to with conventional methods. So yeah, I have to agree. We need to go there. It is something that will significantly reduce our energy consumption as a people. And, I think we'll find it has some other benefits as well. Very likely will last longer than the old conventional burner. One furnace I had a designated lifespan for the heat exchanger of 10 years. Never mind that I pushed it way past that. But this is a norm for people where they hear this and they go, well, I guess I'll be replacing my furnace in 10 years. But here you picked a system where you're hoping at least that it'll last, 20, 30 years. The math supports that despite the greater investment, I guess. That's good news too. But what's funny to me is that you're getting into the nitpicky arguments. It's a little bit like, I'm not going to buy an electric car until I can fill it up the same way I can fill up my diesel. Okay.
Yes.
For why? Oh, well, you're really not buying that thing so you can go out and find public infrastructure to charge with, are you? You're supposed to be thinking about charging that at home and at work, where it becomes kind of a moot point. Anyway, the nuances in heat pumps, I'll use my wife's argument. I like the mini splits. They're really easy to install. Yep. She thinks they're ugly. There's nothing I can do with that. No technical argument in the world is going to beat it's ugly. So, okay, trump card it was. And we don't have any mini splits at our house. But anyway.
That actually came up. That actually came up in my house. Is like when we were looking at what to do, mini splits were on the table. And then it was kind of like, but they're big and they're ugly and we don't want them hanging off the walls. So it was like, okay, that takes that off the table. But it was like, there's amazing technology right there. It's really, really cool.
Yes. I'll make sure I keep budgeting for the real system I need. That said, you already hit the nail on the head. The hybrid systems that have their own integrated either resistive heater if it's electric or even a combustion furnace if that's your preference when it gets really cold. The few times you should need that per year should not make it a criteria for your selection of the technology. But, all right, so I think that kind of takes us into some other things related to the home. We've got battery technology that we're first and foremost familiar with in cars. So, in the beginning, my first experiences were about the use of cobalt as a chemistry company I did a bunch of work for, said no cobalt. It was this terrible word, and it was synonymous with danger and risk, and we shall not have that in our cars. And then Tesla came along and made cobalt work, and everyone said, hey, wait a minute, they can't do that. And oh, wait, they did. Maybe we should do that too. And now, we've got lots of cobalt, but it's kind of become the new blood diamond, so we're looking to get away from that. And there's a lot of different technologies that are candidates to replace it. We read a lot about LFP, now more recently sodium ion, the redox flow systems, lithium sulfur. NASA's got this new greatest thing since sliced bread, a selenium sulfur battery. And it doesn't seem like a day goes by without reading about some new innovation in batteries. So we are focused first on getting the range and the performance that we need from our cars, but it directly applies to our home and what we might be trying to do to provide a backup to the rather frail power grid we have, and or doing our part to help bolster that power grid. So, all the acronyms, NCM, LFP, XYZ. There's no shortage of alphabet soup out there. Which are your favorites? Where do you see this going? You've probably spent more time researching it than I could ever even imagine having for myself. So interested in what you say.
Well, the one thing I always say whenever I talk about batteries in any of the videos I produce is always there's no one chemistry to rule them all. There's going to be multiple winners in the future, in the next 5-10 years, because it all depends on use cases. Like a battery that might work extremely well for vehicles or airplanes because it's super energy dense and lightweight, the costs might be too expensive and not make sense for use in your home. So it doesn't mean that there's going to be one thing to do across the board. But when you're looking at all the acronyms and the battery soup, the ones that jump out at me are the tried and true LFP. It's like that battery is already here. It's great. It's fantastic, especially for home use. But for the future, it's like the sodium ion is one that I'm keenly interested in because it's a material that's readily available. It's cheap. And so it's like long term, it seems like the smart play to go down that path. There's a lot of potential there. But there's also like lithium sulfur is one that's caught my eye over the past year or two. Sulfur has a whole lot of problems in batteries, but those problems are slowly getting kind of chipped away. And as they get chipped away, there's a lot of technologies that are starting to kind of form around that look really impressive. Hopefully they pan out. It's a little too early to say at this point, but it looks promising. There's another technology, niobium. Do you know much about the niobium chemistries?
No, tell me.
There's a company called Battery Streak that is creating niobium batteries. Now, niobium is a little more of an expensive material when you're looking at the current prices, but what that battery can do is just kind of astonishing. It can like fast charge in minutes. It can take a pounding on charge-discharge cycles and have virtually no degradation, and it can last for essentially forever. An astonishing battery. Of course, it's going to be very expensive to start out, which is why Battery Streak is currently, at the moment, they've partnered with the military, and they're working with the military on creating energy storage solutions for them, which makes sense. Military has deep pockets. They want a battery that's literally bulletproof and can last for years and be really robust. So it's like I'm kind of keeping my eye on that one because if they can kind of get past that, it's kind of expensive upfront territory and get the costs down, it's a very appealing looking battery to me. So I'm keeping an eye on that one as well.
Oh, that sounds good. Again, more info for Tom. I love to walk away with subjects I want to research. So, you mentioned the sodium ion. That one has particularly caught my attention. One of the things that I've read about it that is really appealing to me from I've had to deal with what are the hazardous goods that are lithium-ion batteries as you try to ship them, and the awkwardness about that, the extraordinary packaging requirements, the hazardous goods hauling permits that are required for the transporters, etc. But sodium ion apparently has the ability to be discharged down to a 0-volt state of charge, where most of our subscribers here are probably familiar with the fact that when you get to 0% state of charge on a lithium-ion battery, it is by no means 0 volts, and it's still very much a shock hazard and an arc flash hazard and things like that. But if I could discharge it all the way to 0, ship it, and then charge it back up again, that'd be wonderful. But there's another aspect of it that I find really intriguing, and I noticed that you had done a session on this at one point or another. I didn't watch the session, so no spoiler alert here for me. But wood for batteries. Making hard carbon from byproducts of the paper pulp industry. It's really intriguing. But you can't just replace the graphite in our cells with that, except for in sodium ion, where there's a little bit more hope being able to use a hard carbon. So what are your thoughts about that? Are we going to be able to tap into what is, in my mind, an impending graphite shortage and be able to utilize some wood materials in place of it? And how soon? What do you think?
Yeah, I do. But this also comes back to, I don't know how widespread it's going to be because there's a couple of companies that I looked into that are doing this now. Stora Enso and there's another one, Lignode, I think is what they call themselves. Both Swedish companies, and they're doing this already. So they're already in pilot testing and already have batteries out there that are being used. It's a very impressive path, but but the energy density on these batteries is really low compared to what you see in an NMC or LFP battery, like by an order of magnitude. Like it's 7 times less energy dense. So it's not something you'd see in a car battery or even like home energy storage at this point. It'd probably be more appropriate for like Internet of Things or like smaller use cases. But it is something that's still early days, and it shows that there is a path there to use the lignin that's kind of part of the paper making manufacturing process. There's like waste material that comes out of making paper that one of these companies is actually taking that waste material and turning it into this product. So it's one of those finding closed loops and different ways to reuse different materials that we've previously looked at as kind of garbage is potentially a great path for energy storage just like this. So it definitely, it's going to be something that we're going to see in the future. I still just have a giant question mark about like where exactly we're going to see it.
Yeah, well, my own research into that kind of showed what you said there, that the energy density doesn't look very good. But it can potentially mix with the normal graphite material that we tend to use more often in lithium-ion batteries, what is commonly used in even the newest sodium-ion. But there is some hope that you won't have to have this particular structure that is the ideal graphite material, and we can use other forms of carbon. But as a mix, right? You use a 50-50 mix of graphite and the hard carbon from wood, or, there's lots of other materials too. Coconuts are, common material for hard carbon, lots of organic sources for that material. So, the point that I wonder about is more about what is an impending graphite shortage. A lot of people are worried about lithium. A lot of people are worried about cobalt. A lot of people are worried about nickel. Not many people are worried about graphite, and I am. So I see, lignin as a potential offset to that, and it's more or better suited, I would say, to some of the chemistries than others. So I look forward to that being part of our all of the above solution to our energy storage needs of the future. So, I assume that you have invested in some battery technology for your home. Are these Tesla Powerwalls, or what'd you get?
In my previous house, I had Tesla Powerwalls. In my new house, I'm getting the N-phase battery system, which are LFP batteries.
Ah, nice.
Yeah.
Okay.
Yeah.
So you like the LFP, obviously not for its energy density, but for its safety. What's the attribute you like about it?
What I like about LFP over an MC or something like that is it's safer, and it has a longer cycle life than an NMC does. So it's a little more of a robust, safer battery. And when you're putting a battery into your house, it's like you want something that's not going to potentially catch fire or have issues of any kind. So LFP is like the safest kind of technology we have at the moment, which is what drew me to it.
Yeah, good call. So, the graphite shortage, we're going to find more use of alternate materials, all different sorts of battery chemistries that are coming. One of the ones you did do a session on, again, I didn't watch it, but the redox flow battery and how it kind of went to China. Is it too late to recall that and put it into use over here? What are your thoughts on that one? That one, when you first read about it, it's kind of an eye roller at first, but then when you dig into it and you think, wow, that's really something. So what were your likes about the redox flow? What should we do with it?
It's very similar to the LFP thing. It's a battery that's incredibly safe. It's very robust. It will last for potentially decades. Speaking of that America kind of lost its patent and gave it away to China for that specific chemistry. They're trying to get that back, and there's an American company that has that chemistry, and they're going to be putting out basically a Tesla Powerwall competitor that is this flow battery that would be like the size of a small refrigerator that you could put outside your house, and it would be a 40 kilowatt hour battery, which is massive and be more than enough for an average house. It's the equivalent of, what is that, like 3 Tesla Powerwalls or so would be one of these units. Yeah, and this unit would last you 30 years. It's like the cycle life would just outstrip anything a Powerwall could do. And they claim that the cost is going to be price competitive to a Tesla Powerwall. So if they can get that price as low as they claim it is, here's this technology that is long lifespan. You buy it once and you literally just forget about it. It just kind of runs in the background. You don't even think about it. So for me, redox flow is another technology that's just extremely exciting. But it comes down to patents, and it comes down to, can they get the cost down? Can they actually do what they say they're going to be able to do? So for me, those are the big questions.
Yeah, and then I'll add another one to that. And, it's a little bit like Tesla as competition to other major automotive OEMs. They're so expensive. We can build a cheap car and maybe, eat their lunch. And just about the time they get to the point where they do that, guess what Tesla does? They lower their price. Oh, hey, yeah, we made our money on these cars. It's all right. We can lower the price below theirs. And, they do the same thing with their Powerwall once the flow battery hits. So,
Yep.
We should never underestimate what they can do with volume and scale. So,
yep.
So other technologies, we kind of beat up batteries a bit here. One of the subjects near and dear to my heart in the all of the above category for our energy solutions is hydrogen. So I don't know how much exposure you've had to that, but I'm always curious to see what people say about that. This is everything from how do you store it all the way to how do you use it, and is there any logic in burning it? So what are your thoughts on the hydrogen future here? It's been the joke of the technical industry for 30 plus years that I can recall. Yeah. Seems to have always been 10 years ahead, and even today it's still 10 years into the future in some ways. But that 10 years is looking a whole lot more finite than ever before, and there's all sorts of new breakthroughs in technology for how to store it, how to create it. Let's not get into the many, many colors of hydrogen. We all just want the green hydrogen. So, what's your exposure to that and your thoughts accordingly?
I'm very torn around hydrogen because there's aspects of how people talk about it being used that doesn't make sense to me anymore. It's like the idea of using it for passenger vehicles doesn't make sense. I think that ship has kind of sailed. But if you're talking about commercial vehicles, like if you're talking about buses or trucks or infrastructure where it's like, UPS delivery trucks that run a certain route, that kind of a thing. It's like where you can produce the hydrogen at the depot that powers those vehicles to do their routes. It's like you don't have to build out in a crazy hydrogen infrastructure to replace all the gas stations out there. That kind of sort of makes sense to me. Another one that I find super appealing is just energy storage, just basically like a hydrogen battery. There's companies that already have these available today where it's like a shipping container sized thing that you could drop for grid scale storage or for a commercial building. And it's got the electrolyzer and the fuel cell, and it's got solid hydrogen storage built in there to kind of store it. Just a full little battery system that generates hydrogen on the spot and then immediately turns it right back into electricity when you need it. Those kind of systems make so much sense, especially if the costs make sense. Like if you're looking for long-term energy storage, that's going to last longer than a battery. A battery is going to slowly drain over time. And here's this hydrogen system that in theory could store that energy for a very long period of time. And then adding to it, you don't have to increase the size of the electrolyzers and the fuel cells. You can just increase a couple more tanks to get more like kilowatt hours of storage. So there's the way it can scale is different from the way a battery can scale. So there's aspects of it that I find really interesting and exciting. But the big linchpin comes down to, it's not even the green hydrogen or what the type of hydrogen is. It's more of a how efficient and cost effective can you make this? Because it's never going to be as efficient as a battery, but it comes down to costs. So it's like, it may only be, let's say round trip, it's 60% efficient. But if it costs less to manufacture and to run than a lithium ion battery system, that's where I think it could take hold, which is why I keep looking at the grid scale storage and the commercial building storage and then the commercial fleets and things like that. That's where it makes most sense to me. I'm curious, what are your thoughts?
Well, you mentioned efficiency, and that's a hot button. And I know you can relate to my analogy I'm about to make here as a software guy. When I learned software almost 40 years ago now, I hate to admit, but they taught us about software efficiency. And back then, memory was really expensive and not very plentiful. And we measured our coding efficiency in bytes. How much space did it take? And then once we got used to trying to make compact code to maximize our use of memory, then the instructors would say, oh yeah, and by the way, it's really important how fast it executes. So that's a different way of assessing efficiency on software. And then I got into industry. And I realized that neither of those things mattered at all. What mattered was a different kind of efficiency they didn't teach us. And that is, how long does it take to write the code? Because when your boss is looking over your shoulder and tapping his foot saying, is it done yet? Is it done yet? Suddenly that becomes the most important thing in the world. So this is what's happened now with energy technologies and efficiency. What we might think of as efficiency, comparing energy input to energy output as a mathematical formula, suddenly there's other elements in play. Is it easier to make? Is it less hazardous to the environment? If it leaks, what sort of havoc does that cause? And I think we're going to reassess hydrogen for those things, and we'll find new applications. But you're right, it's a really kind of a scary thought. There's still way too many people that are old enough like me to at least have read about the Hindenburg disaster and everything that represented. And, we're smart enough, I think, to avoid yet another catastrophe like that. But we'll have our own little mini versions of that. You got Toyota. They have a Yaris GR, I think it is, a race car they built up that Akio Toyoda himself was driving as the driver for a couple of years, and now that he's gone, that's kind of moved on. But they moved to liquid hydrogen, and that's like the bridge that everybody doesn't want to cross, because that one, as soon as you start doing the math, the math doesn't work on liquid hydrogen. It has to be way too cold and takes too much energy to get it there, unless it's a race car. And then it becomes about how fast can I fill up, how far can I go between fill-ups, and how big is my fueling rig? And they reduced the size of their fueling rig quite a lot by going to liquid hydrogen. But they no sooner got that off the ground and they had a fire and kind of set themselves back. They're back in business with that car. But it's an interesting topic to see whether or not we'll get through all the safety concerns, all the concerns about it permeating through just about every kind of container you can put it in, et cetera. So, interesting. So I got one more topic for you. And I know it's a subject that you did a session on, so I'm expecting again to learn a thing or two here, and that is Neuralink. You're a specialist at human-machine interfaces, or GUIs as we like to call them in the software business, but this is like the ultimate GUI. Right, we now have a man-machine interface that works with thought. And although it's starting out at a very small scale, those of us who have been studying this a while know where it's going. So, in the beginning, it's going to be about the handicapped person that gains new capabilities, and that'll all be great, and we'll all really be happy that the technology is there. But then there'll be all those people going, every new technology has some use towards ill will, and this could happen here too, very clearly. But what I think is that as soon as two people have this in their head, and the software is accommodating, we've created something amongst our humans that we've never had before. At least not that we've been able to recognize the technology behind, at least, and now we can. And that is what I call telepathic communication. If you and I had a Neuralink setup and the coding was appropriate, we could be having this discussion at about 1,000 times the rate we are right now. So, what's not to like? This conversation would have taken
like half a second.
Exactly, and because we've done that, have we evolved as a species by having done that? I don't know. What are your thoughts? Get out in the weeds for me here.
Okay, I would say yes. I'm a sci-fi geek, this is like where you see this in sci-fi stories all the time, where this seems like an inevitable path we're on right now. And it could be either the best thing that's ever happened to us. It could also be this dystopian future that we're heading towards. And so for me, I don't know which way we're heading yet, because there are so many ways this could go wrong. But when you think about the potential of being able to offload parts of your consciousness or your thoughts it's going to expand what we can be and what we can do. Like you just mentioned, like the telepathic, be able to talk to each other in a way where we're not using our mouths. We're not picking up a phone. We're communicating instantaneously just through thought.
Or the god-awful keyboard. Oh my God, that's the worst.
Yes. Yeah. You've evolved as a species at that point. If we can achieve that you will have evolved as a species. At this point, it's way too early to call, but it's also, you can see where the hockey puck is going, to use an overused analogy of skating to where the hockey puck is going. You can see where it's going. So it's I don't know. I'm so torn on this one because there's so many good potential use cases for it, especially the short-term ones about potentially helping people who are handicapped or have some kind of ailment that this could actually literally bridge, like a severed spine. There's so many different potential use cases, but just for us as a human species, this is going to be a massive paradigm shift like we've never seen in human history before if we can pull this off.
People worry about AI, maybe taking us over or whatever, but to me, it's just a way to stay one step ahead, right? Best way to beat AI is to be AI, in my view. So, and you look at the technologies that have come and gone, most of them here to stay, everything from fire to the wheel, and everything thereafter, it's always had, a greater good that was its cause. And there's always that little minor use of it that was for some ill will. And this will be no exception. And it'll require us to be on our best game to make sure that we stay on the right side of that formula. But I'm not afraid of it. I'm ready for beta testing. Bring it on. I use Google 20 times a day as it is. It'll just turn into 1,000 times a day that way. So,
well, let me ask you a question. If beta opened up in the next 5 years, would you sign up? Would you be like, I'm willing to give that a shot?
It would depend a little bit on some of the details. Are we talking about FDA approval at that stage and, widespread adoption of its safety and the software provisions that, are, appropriately firewalled, if not antivirused? I think I'd do it. I would.
Wow.
Because I think it would add to my capabilities as an engineer, as a podcaster. I imagine all the things I could have been thinking about asking you that I failed to do because I didn't have a high bandwidth connection to the internet while I was talking to you. So maybe we'll have this discussion again in 10 years.
Yeah. We'll think it.
Yes. Well, Matt, this has been a lot of fun. I enjoyed it immensely. I learned quite a few things. I'm pretty sure our users, our subscribers did, both yours and ours. So, I appreciate your time today and your insights and, keep going.
Thanks so much. Thanks so much for having me on.
I have a new geek's geek to follow. So thank you for that.
I appreciate it. It was a lot of fun.
All right. Thanks, Matt.